We saw in the previous video that there's a lot of limitations to even simple things like addition and subtraction using Java. You might say, well, if this is a problem of using floats, why not just use doubles all the time? Well, the thing is, you'll run into similar kinds of problems with doubles. There's all these little round-off errors. This is really what is happening here. This is a limitation of using finite precision for floating point numbers. In the real world, we expect everything to be infinite precision, like we're used to in mathematics. It turns out when you use computers, it doesn't quite work that way all the time. There are tons of little limitations that we'll run into. So you might say, well, maybe if this is a Java problem, let's switch to another language. No, that's not going to solve your problem, because you get the same problem in C++, C#, Java, C. Basically, they use the same hardware, and that's the problem. You might say, well, let's get better hardware. Even if you double the precision of your hardware, you'll still get situations like this. They'll never go away unless you have an infinite precision chip, which is pretty much impossible. So the best thing that we can do is be aware of these things and just say, okay, there are going to be these kinds of possibilities. If I add two numbers and if I think I can do this better in my head, well, you're right in this case. You can do this better in your head. The answer would be 300,000 0.02, but the number that gets printed out in a program like this is 300,000 and 0.03. Okay, and the reason for this is the fixed precision of floats is about 8 digits, and it's not 8 digits everywhere, but it's roughly speaking, so you can think of it as 8 digits, I guess. Okay, so we saw this problem with floats. We also saw this with doubles, something as simple as 1 minus 0.9. I can do that in my head, but the computer, which is supposed to be really powerful, cannot do this simple subtraction and get it right. And really what's happening is the hardware limitation. The best programmers, what they do is they say, okay, I know there are these limitations. I'm just going to always have to be on my toes when I deal with floating point numbers, and always be prepared that you can do something like this. Have 1.0 minus 0.9 and not get 0.1. And the reason is it's not easy to do exact arithmetic even with double precision. So the best programmers will just have this take this into account and expect things like this. And when they debug, they can remember this fact. Okay, double precision numbers does not give you perfect representation of every single number. It's like 0.1 is a problem. Okay, now let's move on to string literal. A string literal is a possibly empty sequence of characters enclosed in double quotes. So double quotes ABC, double quotes 1, 2, 3. These are all string literals. In this case, this one is an empty sequence of characters. There are no characters in that sequence. You can also have character literals using single quotes. So single quote A is the character A. And you can have a single quote 1, single quote 2. Those are representation of characters and not numbers. So that distinction is important. You can also have you can also use special what are called escape sequences. So you can say, let's say you want to represent a single quote or a double quote. How do you do that? You can't say quote quote, that doesn't make sense, or quote quote quote, that won't work. You'll get error messages. And let's just take a look. So we're trying to do something as simple as set a character value C is equal to, and we just want to have a single quote character so that we can print it out. So can we do this? No, it turns out we can't. System.out.println C is plus C. Okay, we cannot do this because, and we cannot say single quote either. Can we do this? No, because single quote has a meaning. It's what starts a character. And then you might say, well, okay, so in that case, let's take a simple one, like A. This will work, right? So if I had A, I just use single quote A, single quote, and it prints out C is A. If I wanted a number, like 9, I can do that as well. Print it out, C, and it'll print out C is 9. Okay, it's the character 9, not the number 9. It's an important thing. And you can do something like U, and so on. You can use semicolon, that's fine too, even though it's a punctuation character. This will work. Now, you might say, well, how about a double quote? Will this work? I don't think it'll work, but let's see. Oh, it worked. Alright, so we don't need to fix that. But a single quote, we cannot set up a character that's a single quote character. Using this kind of technique, we give an error message. So what do? We use an escape sequence. So you put a backslash character. What this does is say, okay, I'm referring now to this character, single quote. No, I'm not using it in the usual meaning, which is that here I'm going to start as character and I'm going to end it with another single quote. So we're saying that don't use the usual meaning of single quote. This is literally a single quote. Now this will work. Okay, so we use the escape sequence or backslash to, and this is a technical word, to protect this second single quote. And we enclose the whole thing in single quotes, open close single quotes, to represent the fact that we are dealing with a single character. Okay, so that's what this means. And sometimes you have to, let's say if you had a string and you wanted to have double quotes in it, a double quote character. Oops. Alright, let me go back to Eclipse and let's set up a string, and let's say that we are doing some dialogue is equal to he said, comma, you're fired. Okay, so you might think, well, you should be able to do that, right? These are double quotes as in a dialogue. Well, what happens is this double quotes just end, this double quotation ends this one. So this is one string. And now you're trying to use this, whatever it is, you, single quote, and that just doesn't work. So how do you print out he said you're fired? You protect this, and you protect this. And then we have to print out dialogue. Dialogue is dialogue. So the whole idea is, how do you represent a double quote inside a string, and strings are usually enclosed in double quotes. Well, you use the backslash character. Alright, so there it is. That's the complete string, and including single quotes and double quotes. So to protect these double quotes inside these outer double quotes, you have to use backslash. That's what this is. What about a backslash character? What if you want to print out a backslash? Well, you protect the backslash with the backslash, so that this whole thing is a single backslash character, even though it doesn't look like it. Okay, character literals. If you have strings and you do a plus operation on strings, what you get is concatenation of strings. So you concatenate this A and the T. It does not work with characters. So remember that single quotes is means that you're going to represent a single character, And with characters, what you do is you cannot concatenate two characters and give you a single character, right? So think of types. Remember that when you take something of type character, if you do some manipulation with them, you have to get a single character back. You cannot get a sequence of characters like AT. So this really has to do with this thing that we've been talking about for a while. I'm going to go way back to Java values and types. What does a type mean? And in this case, I'm going to go forward again. We're dealing with the type character, CHAR. So let's go forward to where we were. This is really the same discussion. When you have two characters, what does it mean to do this operation of plus on them? It turns out, when we're talking about characters, what we're doing when we do plus is integer addition. So we're adding the ASCII representation of the letter A and the ASCII representation of the letter T, and gives us some ASCII number that we don't know what that represents really. It turns out it's the sum of those two is 181. And we don't know what the character represents, but if you print it out, you'll get 181. So if you print out double quotes A plus double quotes T, we are going to concatenate those two strings. That's what these things are. They're two separate strings, and the result is another string, which is the concatenation of those two strings. If you do the same kind of thing with characters, what you get is a number. And in this case, you take the ASCII equivalent of A, ASCII equivalent of T, add them together as integers, you get 181. So at first glance, this might think like, this is crazy. It's, Java programming languages shouldn't work like that. Actually, they should. This is how they're supposed to work. And you just want to be able to figure out this logic. That's the challenge, really, of programming. Okay, there are other things that are useful for formatting, like \T represents tab character. If you want to line up stuff into columns, then you would use \T. \N represents a new line character or end of line character and gives you a new line of output. There are Boolean literals like true and false. They have the obvious meanings, and I'm hoping that you've seen all of that. A variable can contain values of only one type. So an int variable can contain only single int values. A double variable can contain only double values. So if you had something like this, int I is equal to 1, float A is equal to I, what happens is you're trying to assign the value of an int I into a float, and you guys probably know what happens. If you're not sure, I'll give you a hint. It starts with the letter P. If you're not sure yet, PR. Okay, that probably gives you enough of a hint. It's promotion. So when you try to assign an int to a float, you promote the int to a floating point number. So A gets 1.0f. Similarly over here, when you assign a float to a double, what you're doing is you're promoting the float A to a double. Actually, let me backtrack and say that you're not actually promoting this float. The type of A does not change. It's just the value that's stored in A will get promoted to a double and get assigned to the variable B. And so when you print it out, you'll get B is 1.0. Okay, so I'm hoping that you've seen all that. Promotion should be something that I'm guessing that all of you have seen this kind of stuff. Okay, the type of value a variable contains is the type of the variable. So an int only contains ints. It's fixed when the object is designed. So when you say int I, it's fixed. You can never change it. Even if you try to quote unquote, if you use parentheses to cast, you're not going to change the type of the variable. So int I always remains an int. So the width of a window might be 100 and at one time 150 another time, but it'll always be of type int.